Mr. True. Okay, well we just got done talking about exponential functions and graphing them. That leads us naturally into logarithms. So I'd like to, if you have a calculator handy, ask you to tell me what is the log of 100. Can you find that button on your calculator? It's equal to 2. Now, what is a logarithm? Well, the book says that the form of a logarithm is y equals log base b of x, where x is greater than 0, and b is equal to greater than 0. Your base has to be larger than, they both have to be positive. And why does log of 100 equal to 2? Well, if we write log, the standard base of log is 10. So log base 10 of 100 equals 2. I always use this example to start off with logarithms because it's one that you might recognize those numbers and you might be able to go, okay, 10 to 100, well yeah, 10 squared is equal to 100, right? Right. So what you can now see is I have an equivalent expression written in two forms. I have it written in exponential form, log form, and exponential form. In this very simple example, which I use all the time in my classes to try and remember to teach kids, what is going on with logarithms. And it's nothing more than when you take a logarithm, what you get out. Look at this form that we are comfortable with. What did we get out? We got out an exponent. The base of the log ended up being the base that we have here in the exponential form. The log of 100, log base 10 of 100 is 2 because 10 squared is equal to 100. So this is our base when we are looking at equations that are in exponential form. Or if we want to go from log form into exponential form, the base of the log is the base of the exponent. And then finally, what is this 100 here? Well, that's kind of like what I call the answer. So the log base 10 of 100 equals 2. That's equivalent to the expression of 10 squared equals 100. Log form, exponential form. So keep this in mind. I'm going to erase this now and write how I like to write logarithms, which is, and this will help you go back and forth in between exponential and log form, is you have the log of a base, and then you have an answer, and what you get out of a logarithm is an exponent. So let's use this pattern, and please put your bases down here as a subscript. Don't make it all in the line because it's going to look like it's all multiplication, or you might be doing like log base 2 of 8, and it's going to look like log of 28, which is going to be incorrect, and it'll confuse your teacher and yourself. Let's use this now to go back and forth between exponential form and log form and see if we can evaluate some basic log expressions. So we're going to take 4 equals the log base 2 of 16, which is a true statement, and just convert it. We're just getting into logarithms, so we're just going to convert it back and forth in between log form that we might not be familiar with and exponential form. Well, this is in log form. When we go to exponential form, it's base, answer, and exponent. So the base of the log is going to be equal to the base of our exponent. What you get out of logarithms, just keep chanting that. What do you get out of logarithms? What do you get out of logarithms? You get exponents. So that's 4. And then what you're taking the log of in exponential form is actually the answer, again, in exponential form. So 4 times log base 2 of 16 equals 2 to the 4th, is 2 to the 4th equals 16. Let's take a look at another example. How about 3 to the negative 3rd equals 1 over 27. Well, is it actually true? Well, it is true. These are all true statements. This is now in exponential form. I don't see a log function in here. And remember, when you have a base to a negative exponent, to get rid of the negative exponent, you would flip the base. So this is 1/3 to the third power, and that does equal 1/27. And to write that in log form, well, it's log. What's the base of the exponent? Well, I almost erased it. It's 3. So the base of the exponent is your base of your logarithm. Then the answer. What is the answer in exponential form? Well, that is what you're going to be taking the log of. So it's going to be log base 3 of 1/27. And then what do you get out of a logarithm? You get an exponent, so -3. And you might be noticing, let me put this back up here again. Log of 100 equals 2, and 10 squared equals 100. You might be noticing that the log function that you're undoing, like I have 100, I apply the log, I get to 2. Well, then I get 10 squared, and I get back to 100. So I'm like doing something. I start with 100, I do something, I get 2. I make that 2 an exponent of 10, and I get back to 100. Exponential form and logarithms, those are inverse functions. It's like addition and subtraction. If you do 10 times 2, I said addition and subtraction, I'm doing multiplication, but 10 times 2 is 20, and 20 divided by 2 gets you back to 10. Multiplication and division are inverse functions. 5 plus 2 is 7, and 7 minus 2 gets you back to 5. Addition and subtraction, those are inverse functions, or opposite functions, if you will. So, a couple of expressions going from log form to exponential form, and exponential form to logarithmic form. Let's take a look at this expression. Let's try and evaluate log base 4 of 64. Well, you might go, well, okay, I tried that and I checked in the back of the book and it didn't work. Or my calculator doesn't do log base 4. Well, no, most calculators only do log base 10 and log base e, which is called natural log. I haven't talked about that yet. What is this equal to? Well, I don't know, and I like to put this extra part in that the textbook does not when they give you these questions and they ask you to evaluate them. Give that whole expression so you can see the base, the answer, and what's going to be the exponent when you write your log function in exponential form. So this is going to be 4 to the x equals 64. And if you're in your first logarithmic section of your textbook, they're going to be giving you questions you should be able to do in your head or without using the log function on your calculator. So 4 to the what power does equal 64? I think that 4 to the third equals 64. 4 and 4 is 16, and another 4 is, yes, it is 64. So x does equal 3. You notice how I wrote it so that the bases were the same, so the exponents had to be the same? That's something you'll be doing a lot when you go to solve equations with logarithms, or solving equations that you don't need logarithms in. Good? All right. So, like you could answer yes or no. Let's take a look at this question. Log base 5 of 1/5. What's that equal to? I don't know. But I know that if the textbook gives me a log function, I'm probably not going to be able to do it because, and again, this has a base of 5, which most calculators won't. Inspires will, but most calculators won't. So let's write this log function in exponential form. Base, answer, and what do you get out of a logarithm? An exponent. So this is 5 to the x equals 1/5. Well, can I write this so that it has the same base as over here? Can I move the 5 up to the top, the numerator, like it is on the left-hand side? Well, I can if I allow it to have a negative exponent. And so, yes, log base 5 of 1/5 is equal to -1. Or, what exponent will allow 5 to become 1/5? Well, that's -1. All right. Let's take a look at another problem. How about log base 7 of 7? Now your textbook might have said that when the base of the log equals the base of what you're logging, that they're always going to cancel out. and that this would equal 1. Well, let me explain why it does equal 1. Let's say I didn't read the book and I don't know what log base 7 of 7 is. Okay, so I'm going to fill up the whole expression with base, answer, and exponent and convert my logarithm into exponential form. What do you get out of a logarithm? An exponent? I thought so. Okay, so that's base. This is going to be the exponent of that base. And then what's the answer? Again, these names, again, one more time, are for when you're converting from log function into exponential form. So 7 to the x equals 7. Well, this had an exponent of 1, so 7 to the x equals 7 must be x equals 1. And if that happened to have been 2, well then it would have been 7x equals 7 to the second power, which that meant x equals 2. Okay, what about this problem? I haven't written a natural log up here yet, so let's let you see at least one of those. The natural log of e to the 5th, well, what does that equal to? Well, Mr. Drew, you haven't even written the idea of ln yet, so let's explain that. Natural log, ln, is log base e, and I'm going to take the log of the natural log of e to the 5th. You see this starting to stack up? You might know what's going to happen now. And, oh, by the way, e is like pi. You know, pi is equal to 3.14, blah, blah, blah. Okay, well, e is approximately equal to 2.718, and that runs on as well a lot. This is a standard number that shows up like in electrical engineering and nature, compound growth. So I don't want to try and derive where that comes from, but e does stand for numerical value. So, natural log is just log base e, and now that you can see these are stacked again, you might think they're going to cancel out, and you would be right, but I'm going to write this log form into exponential form, and see the base, the exponent, and the answer, okay? So, base, you get out exponent out of logarithms, and this is our answer. Well, look. I've got a very simple equation. Both sides are equal. Same base on both sides. So yes, indeed, the exponents must be the same. Or, of course, you'll see this enough times and you'll go, oh, those bases match up. Let's drop it out and say it's x equals 5. All right. Let's see if we can squeeze some more in before my 13-minute buzzer goes off. How about 10, there it is, I got 2 minutes. 10 to the log, or 10 raised to the log base 10, not that I need to write it, of 3. Well, your textbook might say that they'll cancel out as well. I don't need to write that 10, I'm going to leave it there. And it'll say, well, this equals 3, but let's figure out why. Well, let's say I don't know what this expression looks like. Now, this expression is in exponential form, not log form. So let's write it in log form. The log, what's the base of this exponent? 10. What is the answer that we're getting from this expression? The answer is x. And then what is the exponent? Well, this is all the exponent. Log base 10 of 3. And you see how I'm going from base, exponent, and the answer from the exponential form. And look, log base 10. And so x, same function, same base, and nothing else going on in the equation, so x has got to be equal to 3. Or, as your textbook would show you, when you have a base and a log base stacked and touching, they're just going to cancel out, and yes, x does equal 3. I'm Mr. True. Thank you for watching, and go do your homework.